Hi, I'm Farah Ismail. In this video, I will demonstrate Lab5 from Module 8. I will show how to create and configure a relational database using Amazon RDS and connect it to a web application. So let's start with task 1, creating a security group for the database. I'm now in the iOS Management Console. Under the VPS section, I go to the security groups. A security groups acts like a virtual firewall and controls inbound and outbound traffic to iOS resources such as databases and web services. I clicked on Create Security Group. I named this group as DB Security Group. Naming is important because when you are working on multiple projects or environments, clear names help to identify the purpose quickly. Also, in the description, I wrote Permit Access from Web Security Group. These notes help other developers or me in the future to understand why the security group exists. I make sure to select the correct VPS, in this case Lab VPS, because security groups are specific when it comes to the VPS. If the wrong VPS is selected, the group won't be applied to the correct resources. Now I added the inbound rule. I choose MySQL/Aurora with its default port. For the source, I select the web security group. This means only the web server will be allowed to talk to the database, improving security by blocking all other incoming access. Now let's move on in task 2, creating a database subnet group. In the RDS section, from the left-hand menu, I choose subnet groups. A database subnet group is a collection of subnets across different availability zones, and it tells the RDS or Aurora where it's allowed to launch database instance inside your VPS. After clicking Create Database Subnet Group, for the name, I enter Database Subnet Group again. Naming matters for future references, especially when you are working with multiple groups or debugging connectivity issues. Then I select the Lab VPS to match the rest of my infrastructure. It is important to all components, the web server, the database, and security groups to be inside the same VPS so they can communicate. Then I choose two subnets in two different availability zones. These represent physically separate data centers in the same iOS region. Now, this step is very important because by selecting subnets in multiple availability zones, we enable multi-Z deployment. This means if one data center goes down, AOS can fail over to the other, automatically keeping the database online. It's a key strategy for high availability and disaster recovery. Now for task 3, creating the Amazon RDS database instance. This is the core of our lab where we actually launch the cloud server database. In the iOS RDS dashboard, I click Create Database. I select Standard Create instead of Easy Create. This gives a full control over the configuration options, which is essential for learning and real-world usage. For the engine option, I will be using MySQL. For template, I choose dev/test. This gives us a fast setup with smaller instance types and no unnecessary overhead. Then I enabled multi-AZ database cluster deployment. This means AWS will launch two instances of the database, one in each availability zone, for automatic failover and high availability. My apology, but there was a mistake recording this step, but I basically copied all the information I'm asked to fill in the setting configuration for the database instance name and the master name. For the instance configuration, I choose D3 Micro, which is small and cost efficient, perfect for labs or deployment. And for the storage, I go with the default 20 gigabyte general purpose SSD. And for connectivity settings, I select the same lab VPS as in the previous steps. I attached the database security group that I created earlier. This step is important because attaching the correct security group ensures only the web server and no one else can connect to this database. And for additional configuration, I give the initial name and skipped the backups, monitoring, and encryption to keep the setup simple and fast. These features are useful in the production but not necessary for this demo. In this step, we deployed a real cloud-based MySQL database using RDS Amazon. We choose the safe defaults for the environment, enable high availability, and connected everything to our VPS. Now, after creating, we need to wait from 4 to 5 minutes for the database to be available. Now, when it's finally available, we go and click on the lab. Then we go to the endpoint. This is how the web app will know where to find and connect the database. If this link is incorrect, the app won't be able to reach the database at all. Then for task 4, I will go to the AWS details and get the public IP address. This is how I can access the web application from my browser. To copy it and paste in a new tab, this loads Lab's address book web application interface. Then I will click in the RDS. Now we fill the fields with the info we are asked for, the endpoint, database name, username, and password. Each one of them is very important because the endpoint tells the app where to connect. The database name ensures we are connecting to the right schema. The username and password for authenticate our access. Then we click on submit. The address book will load eventually after a few seconds. Now here is the address book. This means the connection is successful. The app loads a working address book showing it's able to read from the database. We can add content, edit, or remove. After I have finished all the tasks, I submitted the lab and got a full mark. And that's it. Thank you.